Okay, so I just want to go through exponential function review with you guys. So if we take a look at our exponential functions, as we did back in units 2 and 3, this is going to be important for us as we go through into our logarithms unit. So if you recall, one of the basic equations would be like y equals 2 to the x, or y equals 3 to the x, or y equals 5 to the x, or whatever. And what we did to sketch the graph of these was we used the points 0, 1, and -1 for x. And we had 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, and 2 to the power of -1, which is 1/2. When we put this on our graph, we had the point 0, 1. We have the point 1, 2 sitting right in here, 1, 2, and 0, 1. And we have the point -1, 1/2, and our graph is bending down in this direction. So if you remember, we also had a one-sided horizontal asymptote line. So this would be a left-hand asymptote, so that as our graph gets closer and closer in that direction, it's hugging towards that asymptote line, and then this end kept going upwards and upwards. So the domain for this was all real numbers, and the range would have been y is greater than 0. So then what happened is that we moved it around. In unit 2, we just did our basic sort of transformations using the main point and stuff like that. And then in unit 3, we brought in the whole idea of y equals a f of b, and then x minus p, and then plus q. So I thought I'd just go with this one. So an example would be to graph y equals 2 to the power of -1/2 x plus 1, and then maybe -3, just to see what that would look like. So the first thing that we have to do, if you remember, is you have to fix the brackets, which means that if you think about the bx minus p part, that part is actually happening up here in the exponent. So we need to fix that first by factoring out the -1/2 in the front. And if I factor out a -1/2, I'm dividing by -1/2, so I would have x minus 2 sitting up in here, and then -3. So then what we're looking for is we're looking for our main point. So the main point of this thing is going to be at 2, -3, and then we would be congruent to all the leftover stuff, which was y equals 2 to the power of -1/2 x. After we have 2 to the power of -1/2 x, we create our table of values as close as we can to that original table of values that we had right up here, right? But instead of using those values, I'd still use the 0, because the 0 is really nice. 2 to the power of -1/2 times 0 is 2 to the power of 0, which is 1. But now I'm going to pick my values more wisely. I'm not going to choose 1 here. I'm going to choose 2, because then when I multiply it, I would get 2 to the power of -1/2 times 2. 2 to the power of -1 is 1/2. I would also choose -2. 2 to the power of -1/2 times -2 is 2 to the power of 1, which is 2. And remember that on this part, we're talking about how far we go left and right from the main point. And on this part, we're talking about how far up, down we go from the main point. So what we have then so far is a starting point at 2, -3, 1, 2, and 1, 2, 3. And our horizontal asymptote line is either going to go to the left or to the right from that point. That's our starting point. But when we deal with this one tells me that I go left or right 0. I don't go left or right at all, but this guy tells me that I'm going to go up 1. So there's that first point sitting right in there. For the second one, this guy right here is telling me that I go right 2 from my main point, and then I'd go up 1/2. So from my main point, which is black, I would have to go right 2 and then up 1/2 to see what I would be getting. So right 2, 1, 2, and then up 1/2. So I'm not going to actually do that or like label that point with its coordinates because it's fractions, so we don't really need to do that. But if we're dealing with this one right here, the -2 means that I'm going left 2, and this guy tells me to go up 2. So from my main point, again in black, I go left 2 and I go up 2, and that's a nice point right there. So as you can see, if I trace these points, this graph is going down to the right, which means that I have now from my main point got a right-hand asymptote line down here at y equals -3. And if I trace these points together, these guys keep going closer and closer to the horizontal asymptote line, and this one just sort of starts bending upwards. We label our points. There's 0, -1. This guy here is at 2, -2. If you want to label the third one, that's fine, but it's really just there to sort of help us to get the shape of the graph and the direction of the asymptote line. My domain for this would be, again, all real numbers, and my range for this would be y is greater than -3. So that's how we sketch the graph of an exponential function. I'll do one more just to make sure that you're okay with it. And what we get for this one, let's do y equals -3 to the power of 2x plus 2. And then we'll go, I don't know, plus 2 again. Sounds good. So the first thing that I'm going to do is I'm going to fix my brackets. So I'm going to get y equals to -3 to the power of 2 bracket x plus 1 and then plus 2. My main point, just like we've done with all of our other graphs, is going to be at -1, 2. I am therefore going to be congruent to all the leftover stuff, which is y equals -3 to the power of 2x. Now, this, remember, is not -3 to the power of 2x. That is not what that is. It is technically negative bracket 3 to the power of 2x. The negative is being multiplied onto this thing. So that when I do my table of values, in which case I'm going to use 0, 1, and -1 again, because I can plug them in pretty easily. When I plug in 0, I'm going to get negative bracket 3 to the 0, which is -1. When I plug in 1, I'm going to get negative bracket 3 to the 2, which is -9. And when I plug in a -1, I get negative bracket 3 to the -2, which is going to be -1/9. So keep in mind that for this first one, I'm going left to right 0. And then now I'm going to go down 1. And for this guy right here, I'm going to go right 1, and I'm going to go down 9. And for this guy right here, I'm going to be going left 1 and down 1/9. So this is going to be what this graph is going to look like. So I'm going to start off at -1, 2, which is right here. And again, my horizontal asymptote line is either going to go to the left or to the right of this. From this point, I go left to right nothing and down 1. So I've got that point on my graph. I go right 1 and down 9. So right 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. There I am. And I go left 1, left from the main point, which is black, left 1, down 1/9, which is tiny in here. And if I can think about how my graph is going, it's bending like this and sort of heading down in that direction. That means that my horizontal asymptote line is moving off to the left here. I have a left-hand asymptote line at y equals 2, and my graph bends up and over towards the asymptote line, and then keeps sort of coming downwards like this, and it does keep going. The points that I've got here are 0, -7. This point right here is at -1, 1. And my domain for this one is all real numbers, and my range for this one would be y is less than 2. One other thing that we talked about with exponential function is, remember, the number e that we are dealing with is our natural growth constant. You're going to see this a lot as we go through this unit. So, well, here and there anyway, as we go through this unit, you're going to need to know that natural growth constant. Remember that E is approximately equal to 2.7182812 something something. You can see it on your calculator. Usually most calculators have at least 2 buttons for E, so you can actually figure out what that number is. When we are dealing with something like y equals e to the x, we just approximate. So that if we were graphing 0, 1, -1 in here, e to the 0, something to the 0 is 1, e to the 1 is e, which is approximately 2.7-ish, and -1, e to the -1, or 1 over e, is approximately, how I think of it anyway, is like 1/3. It's a little bit less than 1/3, or a little bit more than 1/3, I guess. So when we are graphing this thing, we would go to 0, 1. That's an easy one. We would go to 1, e, so 1, 2.7-ish, and I just label it as 1, e. I'm estimating. And we go -1, about 1/3. And of course, with this shape that it has right here, as we go down with this shape, you can see that we are also getting a left-hand asymptote line. So it's acting just like like a regular number does, because it is just really technically a regular number. It's just approximately equal to 2.7, and it is called our natural growth constant. So before we come back to school, I need you to make sure that you can graph and recognize the exponential graph. Now to do that, you can, if you understand this lesson here, that's great. You could go back to Unit 2, you could go back to Unit 3, or what you could do is you could do Day 2 in the Unit 7 homework package, just to make sure that you are sort of up to speed and ready to sort of get going really fast when we come back to school on Monday. I am going to cut a couple of days for the unit, but we are going to be getting through most of the logs unit. Hopefully everything's all good. And yeah, so if you can get this done, that would be fantastic, and see you soon.